So in this case, we are going to consider a typical exam revision as we are preparing for the exams or for the control tests that we have, which is ahead of time. We need to at least practice as many question papers just to get an understanding of how do they ask these questions. So this is a June 2024 exam that we are going to work with for our grade 10 mathematics, and that it was paper one. We are also going to consider the paper two, and like I said before, we are going to have revisions from different provinces so that at least we can see typical questions that they are simply the same. So this is from the GAUTENG province. We are going to have others as we are preparing for these tests that we have. So this was a 1 hour, 50 marks, as we can see. Let us quickly go through the questions as we have our instructions and information. Make sure that you read everything. So we have got 5 questions that we are going to be working with, and make sure that your answers, they are being rounded off to 2 decimal places unless stated otherwise. So that is it, guys. Make sure that you read all the instructions that you are given there. Like I said, we are going to quickly go through our questions. On question number 1, it was a simple question, but we need to understand the question. The question is, if X is being an element of these, that is the values of X that we are given, for these values, we are only given from 0 up to 4. This is what you're given. That's 0, 1, 2, 3, and 4. So they are saying, for these values of X that we are given, write down a value of X. The answer is supposed to be, what is the value of X? That is the one that we are talking about, such that K is equal to this part. All right? K is this part, which is containing or having X. We can see that there is X there. But in this condition, this K that we are given, they want a condition that it is 1.1 undefined, 1.2 rational, 1.3 irrational. So guys, for us to simply answer this question, let us just substitute these values as they are and see which one of these is going to give us what is given on these answers, on these questions that we have. So let us start with X being equal to 0. When X is equal to 0, we are going to substitute in place of X here. As we can see, our K is equal to the square root of 9 minus everything over 4 minus 0, like this. In place of our X, we are going to substitute a 0 there. So this is the condition that we are having. So simplifying this, what are we going to have? That was going to be 9, 4 minus 0, that's a 4. So see, simply we are going to have the square root of 9 over 4, which we can evaluate, guys. We know the square root of 9 is 3. The square root of 4 is 2. Or we can simply use our calculator when it is like this. That is the square root. Then we've got a fraction there, 9 over what? Over 4. So as we can see, that's 3 over 2. So 3 over 2, it is a rational number. Remember, rational numbers are the ones that can be written as a fraction, A over B. So meaning to say, for this condition where we are having a rational number, it is from where? It is from a condition where X is equal to 0. So we are having what? A rational number. So here, X is equal to 0. All right, let's have another condition when this X is equal to 1. So that is what we have here. Our X is 1. So when X is 1, we're going to substitute a 1 here. What way we're going to have? It was going to be K is equal to the square root of 9, okay, everything over 4 minus 1, which is 3. So we can simply use our calculator, or we can just simplify 9 divided by 3. this one was going to give us 3, but it is under the square root. It is under the square root. So take note, if you wanted to simplify each, it was going to be difficult because we cannot simplify the square root of 3. So like I said, we can even use our calculator to see the square root of 9 over a 3 like this. So that was going to give us the square root of 3. As we can see, guys, the square root of 3, it is an irrational number. The square root, these are like our sets. Square root of 3, square root of 2, square root of 3, square root of 5. These ones that we cannot simplify exactly. That is the irrational number. So as we can see, when our x is 1, we are having what? An irrational number here when our x is 1. All right. Let us move to another condition, another part of x. When this x is 2, so when our x is 2, in place of x, put a 2 there. What are we going to have? Our k is going to be the square root of 9, all right, over 4 minus 2, which is 2. This one we cannot simplify, guys. Even if we check on our calculator, the square root of 9 over a 2 like this, it is not exact. As we can see, we have this square root of 2 as a decimal. That's an endless decimal that we have, meaning to say we have got what? An irrational number. So that is when x is 2, we are having what? An irrational number there. So, or when x is 2, all right, we move on to 3. So this is how you answer this, guys. Just substitute direct. When this is 3, this is what we have here. Substitute a 3. As we can see, it was going to give us 9, the square root of 9 over 4 minus 3, which is 1. And that is the square root of 9, which is 3. So as we can see, 3 can be written as 3 over 1. So that's a rational number. So we are getting a 3, which is a rational number from what? From the x, which is 3. So meaning to say, when x is 3, we are going to have what? A rational number there. When x is 3. All right. The last number that we have there is what? Is a 4. This is what we have. So when x is 4, that's 4 minus 4. So take note. In this condition, we are having something like this. The square root of 9 over 4 minus 4, which is what? Which is a 0. Let us go back to our numbers. Can we simplify 9 over 0? Remember, if the denominator is having a 0 like this, it is undefined. We cannot simplify that one. All right, let us get our calculator. 9 over a 0 like this. As we can see, that simply gives us the math error to say this cannot be simplified. So if the 9 over 0 cannot be simplified, definitely this one cannot be simplified when it is under the square root. So meaning to say this is going to be undefined. So when x is equal to a 4. So when x is equal to 4, we're going to have what? Undefined. So these are the answers that I was expecting you guys to have at the end for this part. The undefined is when x is 4. The rational numbers are the ones that we have when x is 0 or when x is 3. The irrational numbers are the ones that we get when our x is 1 or when our x is what? Is 2. So moving on to another question. Question number 2, simplify 2.1. That is to simplify the following. All right, so that's 2.11. This part, as we can see, 2 marks for that. So this is corresponding like this. All right, so let us see what we are having here. So as we can see there, we have got a bracket that's 2b into a bracket of b minus 5c raised to the exponent of 2. All right, remember there is an expansion that we use, I said in short, that if we are given a minus b squared, it is equal to a squared minus 2ab plus b squared, which is the first squared Then it's minus 2 times the first times the last plus the last squared. So if we are to notice that condition, let us use it. Yes, we can have conditions, guys, whereby we're going to expand brackets. There are two brackets, it's fine. So in this case, if you're using this, you just consider this is your A and this is what? This is your B, just like what we have on this bracket being raised to the exponent of 2. So this is the bracket raised to the exponent of 2. So we're just going to take like our A and this is our B. How are you going to expand? So like I said, I'm going to have another way. So let us start with this one. So you said you're going to have A squared. From this expansion, you're supposed to know this, guys, from our basics of our algebra. So A squared means the first term, our first term here, which is B. So you're going to have B squared. So B squared, guys, is just B squared as usual or as normal. So that's B squared. Then we move on to the minus 2AB. So it's minus 2 times our A, which is the first term, which is B, times the last term, which is what? Which is 5C. So if we're to multiply minus 2 and 5, that's minus 10 BC. So this was going to give us minus 10 BC plus B squared, which is the last term squared. Our last term is what? 5C. So it was going to be 5C squared. That's 5 squared, which is 25. C squared, everything is raised to the exponent of 2. The 5 is raised to the exponent of 2. The C also. So this is how you can use your identities that are under algebra. If you understand this, guys, you can just expand like this. Then we can use the 2b, which is outside of the bracket. Remember, there is a squared here. So you do not start by expanding with the 2b inside. No. Now we do not have any power here. It's just like raised to the power of 1. So it is easier now for 2b to multiply each and every term, distribute that 2b into the bracket. So let us multiply 2b times the b squared. So that is going to give us 2b to the exponent of 3. This is 1 plus 2, which is 3. All right. 2b multiplies this part of minus 10bc. So that's positive to a negative, which is negative 2 times 10. That's 20. The b and the b will give us b squared, and that's a c. We have the same 2b multiplying the 25c squared. So that's 2 times positive 25, which is 50. So that's 50 b c squared. So this is what you're going to have at the end. You're going to have this. So here, guys, I'm saying we could have expanded these two brackets here, the b minus 5c squared, in another way. This part here, we could have expanded the b minus 5c squared. What does it mean? It simply means there are two brackets there that you're going to multiply. It's the b minus 5c multiplying itself, b minus 5c. Remember your FOIL method. Starting with the b, let us expand b times b. So this is what we're going to have there. So that's b times b, which is b squared. Multiply the b and the minus 5c. So b times minus 5c, that's minus 5 bc. All right? We are done with the b. The minus 5c multiplies here. So it's minus 5c times b, which is negative 5bc. It was supposed to be negative 5cb. Remember, cb is same as what? bc. So write the order in the same order here, the same order that you did on this part. Maintain it also on the second part. All right. Then the same 5c that we are seeing here is going to multiply the last term that we are seeing, minus 5c and minus 5c. So it's like this. Minus 5c times negative 5c. Negative 5 times negative 5. That's a positive. Negative, negative. That's positive 25. C times C, that's a C squared. And remember, you have got like terms, the BC part that we are seeing here. There's a BC, there's a BC. So those are like terms. So it's going to give us B squared minus 5 minus 5. That's negative 10 BC plus 25 C squared, like this. So as we can see, that is the same answer that we are having here in this bracket, this part here. This. So after you expand it by what? By the 2b. So here I'm just explaining to say we could have expanded this way by having two brackets. It's up to you, or you can just use this concept, the identity of our algebra when raised to the exponent of 2. All right, so that's it, guys. As you can see, because of 2 marks, they know that you've got those identities that you can use in an easier way. That's why you see they are trying to budget the marks like that. All right. Anyways, guys, let us consider 2.12. This is not 3x. It is 3 to the exponent of x, like this. 3 to the exponent of x. That is how it was supposed to be given as, all right? Minus 2 times 3 to the exponent of x minus 1, everything over 3 to the exponent of x plus 2, plus 2 times 3 to the exponent of x plus 1. So this is what you're given. The question is simplify. What is it that we are supposed to simplify? These are exponents. Laws of exponents are to be used if they are laws of exponents. But if we are to consider properly, there is something here, 3 to the exponent of x, 3 to the exponent of x, 3 to the exponent of x, 3 to the exponent of x. I said, whenever you have got something like this, try by all means to apply your factorization. Yes, guys, you can work with the K method. It's up to you, but you can just factor the 3 to the exponent of x. How is that possible? Remember, I also said, if we are given 3 to the exponent of x plus 1, it is the same as 3 to the exponent of x times 3 to the exponent of 1. Whether there is a negative 3 to the exponent of x minus 1. This is 3 to the exponent of x times 3 to the exponent of negative 1. I explained, whenever you separate this, use a multiplication and the sign that you are given on that number. Remember, guys, if you multiply these two, you add the exponents because the bases are the same. So if you are to add x plus minus 1, that's x minus 1. If you are to add the x plus 1, that's x plus 1 that we see. So in short, do not even worry to say, I have a negative. Yes, so I can separate as 3 to the exponent of x over 3 to the exponent of 1. It is one and the same thing. It's one and the same thing. I'm not saying it's wrong. But we can simply separate it with a multiplication as it is. So meaning to say, where the 3 to the exponent of x is, there's no separation there because that is what we want. So it's just going to remain as it is. But let us move on to this part. This is 2 times 3 to the exponent of x minus 1. So like I said, we can separate in this form. So what are we going to have from that one? It is going to give us 3 to the exponent of x times 3 to the exponent of negative 1. All right? We move on to the denominator. All right? To the denominator, there's the same thing here. 3 to the exponent of x plus 2. All right? There is a separation to be done. How are we going to separate 3 to the exponent of x times 3 to the exponent of that power that is remaining with a positive as it is? We are done. We have got this part that we are given. So as we can see, that is plus 2 times. We have 3 to the exponent of x plus 1, just like here. So it's going to give us 3 to the exponent of x times 3 to the exponent of 1. The separation that we are doing here can allow us to factorize this separation that we have. It can allow us to do a factorization, since the 3 to the exponent of x is common, let us start with the numerator here on top. There are two terms. This one, it's a term. This one, it's a term as it is like this. It's a term. Remember, it's under a product. Separated by what? By this negative. So it means factorization can be done because this is on its own and this term is on its own. So we can separate to say the 3 to the exponent of x here is common, this one. So let us separate it. Let us factor it out. So as I factor 3 to the exponent of x in the numerator, what am I going to remain with here? If I remove it here, what am I going to remain with? That's a 1. This is same as 3 to the exponent of x times a 1. If the number is not given, it just means there's a 1, not a 0. No, no, no. You replace with a 1. So if you factor out 3 to the exponent of x, you're going to remain with a 1. Minus, you factor out 3 to the exponent of x, you remove it, this one. What are you going to remain with? You're going to remain with the 2 times what? 3 to the exponent of minus 1. So this is what you're going to have. 2 times 3 to the exponent of negative 1. We close the bracket. Same thing with the denominator. We factor out the 3 to the exponent of x, which is common. There's a 3 to the exponent of x here. There's a 3 to the exponent of x here. So let us factor it out. So factoring out the 3 to the exponent of x, you are going to remain with this part. 3 to the exponent of 2 plus, you factor out this, you remove it, this one. You're going to remain with 2 times what? 3 to the exponent of 1. So that's 2 times 3 to the exponent of 1. That's how you answer these questions. So the idea is not about this common test that we are revising now. The idea is for you to have the basic of how these questions are given. Then you attempt as many as you can preparing for your tests. They won't give us exact questions, but they give us similar to this. They'll be similar. Similar approach always. So when you have got something like this, you factored out the 3 to the exponent of x. These two can be cancelled because they're like two terms separated. So you can cancel this. We are remaining with these. Here, do not worry, guys. Use your calculator, guys. Here, do not even worry at that stage. Use your calculator. So we can simply say on the numerator, 1 minus 2 times. So this is 2 times 3 to the exponent of negative 1 like this. So that was going to give us 1 over 3. So the numerator is giving us 1 over 3. Divided to the denominator. What are we going to have? Let us use our calculator also. 3 squared plus 2 times 3 to the exponent of 1, which is just same as 3. So that was going to give us a 15 like this. So we have got something like this, 1 over 3 divided to 15. Remember what it means. It means 1 over 3 divided to 15 like this, which is same as 15 over 1. So it's same as 1 over 3 times, you introduce a multiplication, invert the second fraction, so it will be 1 over 15. So numerator to the numerator, that's 1. 3 times 15, which is 45. So it was going to give us 1 over 45. Or you can simply use your calculator as well. That is 1 over 3. Okay, like this, then divided to the answer that we obtained, which is this 15. It was going to give us 1 over what? 45. Just like that. So these questions, guys, they are in your hands. They are in your hands. Someone can even introduce the K method on this part on how we're attempting this question. Still, you're going to have same answers or same values at the end. So I want you guys to do as many questions as you can of this similar approach if you have challenges. All right. On question 2.2, you're given to factorize completely this part. All right, so this is what we have, a squared minus ax minus 1 plus x. Remember, I said when you are given 4 terms like what we can see in this expression. There are 4 terms, 1, 2, 3, 4. The best way of doing the factorization there is by what? By grouping. We are supposed to work by what? By grouping, where we're going to separate these terms into 2 and see if there is anything common, anything common. But if we are to do so in this case, you are going to notice, all right? For now, do not write anything, guys. I want you to just understand here. You are going to notice that if you were to separate like this, there is only A which is common. Then you factor it out, it was going to be A minus X minus 1 plus X, which cannot be factored. There's nothing common, there's nothing common. So it was going to be difficult if we let it this way. So the only way was to rearrange first. So we cannot take this consideration of just, okay, let us separate into 2. That's not how we answer this question. You check first, is it possible? If not, then rearrange. So how can we rearrange? If we are to check, these 2, we say they cannot go hand in hand. So what about this one and this one? Is there anything common, guys, between A squared and X? We are making things worse. There is nothing common there. So forget about these 2, all right? But there is X here and there is X. At least there's something common. So the question is, what about these 2 that are remaining? Because as we are to rearrange, you're not thinking about one part only. Think about everything. What about the A squared minus 1? Is there anything common? No, there is nothing common. So is that going to help? Okay, the A squared minus 1, which is not common, it has something special about it. Remember, it is a difference of 2 squares. It is a difference of 2 squares. So with that case, we can make that work because a difference of 2 squares can be factorized. Yes, we are rearranging. There is nothing common, but it is a difference of 2 squares. It can be factorized. So that is how we are going to rearrange. So we are going to take the A squared followed by what? Minus 1. A squared minus 1. These 2 following each other, the order is in your hands. But as we can see, we are starting with the A. So let us just also start with the one that is carrying what? That is carrying A. So that's minus AX plus X. Remember, we say these 2. They're going to be together. These 2 together. Now we can group them into 2. Remember, we said, yeah, yes, there is nothing that is common, but it can be factorized because it is a difference of 2 squares. That is why we are so bold enough to take this part. Otherwise, it was not going to work if there was nothing common there. Unless on a consideration that when you factorize here, you get this part, even though it is not having common terms. If it is like that, it's not a problem. All right? But in this case, we said it is what? A difference of 2 squares. Remember our difference of 2 squares concept. A squared minus B squared is equal to A minus B into A plus B. So here, this is A squared minus 1. 1 is same as 1 squared. Does not change. So this is our A, this is our B. So if we're going to have A minus B, it means we are going to have A minus 1. The square root of A squared is 1. It's A, sorry. Then the square root of 1 is 1. So it's A minus 1, A and 1. These are the ones here, A and B. So A minus B, that's A minus 1 into A plus B, that's A plus what? A plus 1. So we have factorized here. That is how you factorize. It's a difference of 2 squares. A difference of 2 squares is not about being common. No, you do not factorize because there's something common there. It is a concept just like a law. So if you know it, you're done. Then for these 2 terms that are remaining, we are going to factor out what? But remember, as we factor out that term, we are supposed to have at least a common bracket to these 2. There are 2 brackets here. So we must have a common bracket to these two, one of these two. If we do not have a common bracket, then it means this rearranging that we did is useless. It does not work. As you factor out, it is not just to say, okay, x here is common. I just say x is common. I factor out x. So minus a here, then x and x is going to be plus 1. I'm done. No. If I check, do I have a bracket which is minus a plus 1? I don't have minus a plus 1. This is a minus 1. It is different from minus a. A must be positive. So it means we are not supposed to factor out positive x. So that is why I'm saying be careful. Do not just factorize there for the sake of it is common. Factorize while least you are checking these two. Am I going to obtain a common bracket? So what are we supposed to factor out? Minus x. Why minus x? All right, let me write it here. Minus x. Why minus x? Because if we check, minus and minus will cancel. X and x will cancel. A is going to be positive. As you can see, A is positive in these two brackets. So at least let us focus on that part for A to be positive. So minus x and minus x cancels. You've got positive A. X divided to minus x, that's a minus 1. X over minus x, like this. This was going to cancel. You get what? A negative 1. All right? So this is the condition. So as we can see, the bracket of A minus 1 is the same as this one. This is the most important part. If this does not occur, guys, it means your factorization is wrong. You must have a condition where there is a common bracket. And what do you do with that common bracket? You factor out that common bracket, which is the A minus 1 that we are seeing here. Since it is common, let us factor it out. Let us take it out as a bracket as it is. As a bracket as it is, A minus 1, we take it out. So if we take it out here, what are we going to remain with? We are going to remain with what? A plus 1. We are going to remain with A plus 1. It was supposed to be like this, A plus 1 in brackets. Then we factor out it here, this A minus 1. What are we going to remain with? We are going to remain with the minus x. So it was supposed to be like this, but these are in one bracket, A plus 1 minus x. But guys, if we expand the brackets, A plus 1 minus x, nothing can be simplified. So it means these brackets that we are seeing on A plus 1, they are useless, these ones. We can just leave it as it is like this. We are done. We are done. So this is the factorization completely done. The question is factorize completely, meaning to say factorize fully up to the last extent that you do not have anything common. All right. So the other question can be like this. Someone can ask to say, okay, maybe I did a mistake to factor out the x here because I said you cannot factor out x. Maybe someone on your working, you factored out x, not minus x. How can you correct yourself? Because it can happen like that. You're under an exam condition. I want you to teach yourself how to correct yourself under exam condition. Let's say you are, this is the condition from here. I'm talking about on this stage. Let me indicate the stage that I'm talking about here on how to factorize here. This is what you're going to do. All right. You're under an exam condition. Then you made a mistake. You factored out like this, minus ax plus x. You factored x because you saw that x is common. Then you just say, okay, x is common. Let me factor out. Then you've got minus a plus what? Plus 1. This is what you're going to get. If you factor out x, if you remove x, you're going to remain with what? Minus a plus 1. So this is how you correct yourself now. You can see that on the first two brackets that you have here, they are a minus 1, all right? They are a minus 1 and a plus 1. This is what we have. But when you factored out here, you factored out plus x. And inside the bracket, there is minus a plus 1. You see that, no, this is wrong because I cannot factor out further because these two brackets, they are not the same. But remember that when two brackets have something similar and we want to make them to be the same, we simply factor out a negative. So we want this bracket of minus a plus 1 to be exactly the same as this one of a minus 1. So how do we go about it? We simply factor out the negative. So this is what we're going to have. It will be a minus 1 into a plus 1. You factor out the negative, the one that is making it difficult for us to have the same bracket. That is the one that you play around on. You factor it out. So the moment we factor out a negative, it means it will affect the x which is outside. So it is going to be negative x. Remember, we factored out a negative. So it's now negative a divided a negative. So negative a over a negative, it will cancel. That's a positive a. Positive 1 divided to a negative. We are just focusing on the side. Positive to negative is what? It's a negative. That's how you correct yourself under exam condition. As you can see, these two brackets are the same. A minus 1, a minus 1. We are simply back to this step at this point here. Here. So factorization, guys, you're not supposed to be limited. You are not supposed to be limited under exam. Learn to correct yourself to say, okay, this is not exactly what I'm supposed to have, but how can I play around with these brackets so that one of these two are the same? Then you factor it out. If you are like that, guys, you are not going to have a challenge in your exams, because sometimes you'll be having challenges to say, how can I make these two to be exactly the same? You spend a lot of time on that. Instead, do what you can, then correct yourself along that way. All right, question number 3. We are given to solve 3.1, solve for x, 3.11. This is 3x squared. All right, 3.11. 3x squared is equal to 2x. Never make a mistake when solving these equations to say, I have x and x, so I can simply cancel x into x. Then this one, x into x, it will be 3x is equal to 2. Then divide by 3, divide. Never make a mistake like that. I said when solving equations, it is best for you to factorize. As you do a division like this, you have removed another solution. As long you've got a quadratic, never do that. Factorize. Take these terms to one side of the equation. A quadratic equation, a quadratic is the one that is in the form of, which is the highest power is 2. Its format is supposed to be like this: ax squared plus bx plus c is equal to 0. That's the format of a quadratic equation. As we can see, variables on one side, one of the sides must be as this one. It must be a 0, one side. Not like this. We do not have one side with a 0. So it is, we have to take this to the other side so that we remain with nothing. We must have nothing on this side. This is the format, guys. Know the format. Know the format. So meaning to say, you were going to rearrange. That will be 3x squared. You take the 2x this side. The moment it jumps the equal sign, it changes the sign. So that's minus 2x is equal to 0. You have the format now. One side is equal to 0. Once you have this, guys, you're done. So how do you solve? Remember, factorization can allow us to solve by having two brackets. So factor out the common term, which is x. X is common. 3x squared divided by x, that's 3x. minus 2x divided by x, that's minus 2, which is equal to 0. Remember, from the zero product, the product of these two to be equal to 0, it means one of these two must be equal to 0 as well. A times B, for it to be equal to 0, it is either A is equal to 0 or B is equal to 0. That's the zero product. The product of two. The product, this one times this one. There's a bracket, so it means that's a product. It's x times this. So therefore, we can separate to say x is equal to 0, or this bracket as it is of 3x minus 2 must also be equal to 0. So that's how you solve. So you see, this one, it's a solution on its own that we could have neglected by dividing by x that time. So it's a solution. We are done with this one. X is 0. There's nothing that we can do. Then we have got this one. What do we have now? We now have a linear equation here. From a quadratic, now we are back to a normal linear equation where we can simply solve by transposing the minus 2 to the other side, or take the minus 2 to the other side, or simply add 2 both sides like that. So that was going to give us 3x minus 2 plus 2, that's a 0. 0 plus 2, that's a 2. How do you find x? From a product, you divide. So divide by 3 both sides. Our x was going to be what? Our x was going to be 2 over 3. So this is what we have. So these are the solutions. X is equal to 0, or x is equal to 2 over 3. These are the two solutions that we're going to have. So as you can see, a quadratic, when the highest power is 2 on your equation, it means you are going to have two solutions at the end. So that is how you solve this. Do not divide by x. You take these terms to one side of the equation so that one side is equal to 0. That's a quadratic equation for you. Let us consider the other types of equations. As we can see, guys, when they give you a question under equations, they can take from any topic. As long from that topic we can form an equation. So there it was from the algebraic. Here from our algebraic fractions, remember you can form equations also. So this is the 3.12. We are given 7 over 3 minus x is equal to 5 over x plus 3 plus the 4 over x squared minus 9. So this is the equation that we are given for 4 marks. Let us see, how were we supposed to solve this equation? There is something unfamiliar in our presentation here. We know it is normal to start with x. But let us consider here on this algebraic expression. Instead, we are starting with a number, not x. So let us correct that part so that it can be x as our first term. How is that possible? It is the first thing that you're supposed to notice are the algebraic expressions in the format that you are used to. As the first thing. Remember, I talked about the factoring out of it. So 3 minus x like this. For us to have x as a positive, was x is negative. Okay, let me start here, guys, so that you can understand me. I'm not saying you are just supposed to have x, maybe minus x plus 3, maybe minus x minus 1. No. You are not just supposed to have x, you're supposed to have a positive x. So when your answer is having x on a negative, let's say it is minus x plus 1, what they do is that they start with a positive number, this one, which is 1. So they rewrite this as 1, ending with what? X, which is carrying a negative. These two are simply the same. We haven't changed anything, guys. Yeah, we haven't changed anything. So minus x plus 1 and 1 minus x are the same. It is just a presentation. But as we want the x to be positive, we do not want just a rearranging of to say it was like this before. No. It is not about to say this 3 minus x before it was minus x plus 3 because they saw that it is having a minus. So they now wrote the positive on the first and ended with, no, it's not like, it's not about that. Yes, this is important to understand, but the concept is how can we make it to be positive? Are we going to just erase it like this? Then it's positive. No, we factor out a negative. By factoring out a negative, it follows that negative divided by negative is positive. That is the case. X is now a positive. That is what we want. The rest, we are not worried about the 3 divided by negative, it's negative 3. Yes, that one we are not worried about. We are worried about the X being positive, this one. So that is the case that I'm talking about there. So if you know this idea, guys, you are not supposed to even go through all these stages. Once you are in exam, you see this. You're just going to have this as 7 over. You see this presentation. You see, okay, what do I need? I want x to be what? A positive. So I just take a negative. Then I have x as positive. You know this one is going to carry what? A negative. Just like that. You're not going to go through, yes, for the sake of understanding. So that's it. But we do understand also that 7 over or a number over a negative can be written in the numerator. So this was going to be negative 7 over what? Over x minus 3. It can be written in the numerator. So this is from this part, all right? It is equal to 5 over x plus 3 plus 4 over x squared minus 9, which is also important. This one, x squared minus 9, a difference of 2 squares. Remember, it can be written as x squared minus 3 squared. So that's a difference of 2 squares where we've got x and what? X and 3. So it's going to be x minus 3. Remember your difference of 2 squares. One bracket is going to subtract. Another bracket is going to add these squares. So it's x minus 3 and x plus 3. So that is it from our difference of 2 squares. So this is what you're going to do first. Rearrange. Make sure, because you are dealing with brackets, so make sure that the brackets here are in the same presentation. Not to say there's a bracket of 3 minus x, which is supposed to be written in the same way as the bracket of x minus. You could not see it if it was like that. Make sure they're the same. Once you've got these guys, it's an equation. Get rid of the brackets now. Get rid of them. I mean the fractions. How do we get rid of the fractions? We find the LCM or the LCD of the given denominators. All right, LCM or LCD of the given denominators. There is x minus 3. There is x minus 3. So we do not repeat that one. Just going to collect it once. There is x plus 3. There is x plus 3. Also, we do not going to repeat this one. We take it once. So this is our LCD or LCM. Then we multiply each and every term by that. Each and every term, I mean, on this one, we are going to multiply by x minus 3 into x plus 3. I mean, on this one, we are going to multiply by x minus 3 into x plus 3. Each and every term on this one, we are going to multiply by x minus 3 into x plus 3. Each and every term must be multiplied by the LCD. Look what is going to happen here, guys. This is going to cancel x minus 3, x minus 3. So we are left with minus 7 into what? Into x plus 3. So that's minus 7 into the bracket of x plus 3. Remember, this is negative 7. This is equal to, we move on, as we saw previously, the x plus 3 this time and x plus 3, they will cancel. So you're going to remain with x minus 3 and what? And 5. So that's 5 into x minus 3. There was a plus here, so that's plus. We do the same. These brackets, as we can see, they are simply the same. So they were going to cancel. They're simply the same. So we are going to cancel as it is on that part. Each and every part. X minus 3, x minus 3. X plus 3, x plus 3. So what were we going to remain with? A 4. So this is what you're going to remain with. Guys, as we have removed these fractions, as we can see, we no longer have a fraction here. We had fractions, so we had to clear fractions by multiplying each and every term by the LCD or the LCM. Now, what is it that we have? Brackets. At this stage, we now have brackets here. So remove brackets. How do you remove the brackets? Distribute by what is on that bracket. Here, minus 7. Here, the 5. We distribute throughout. We are done. So that is it, guys. Negative 7 times x. This one, negative 7 times x was going to give us negative 7x. Negative 7 and 3 was going to give us negative 21 if we multiply. That's equal to, we distribute here 5 times x, that is 5x. 5 times negative 3, that's a negative 15. The 4 is on its own. We do not have a bracket, so we're just going to write a 4 as it is. So as we can see, guys, on the left-hand side, we do not have any like terms. So we're just going to rewrite as it is. But on the right-hand side, we have got like terms, the negative 15 here and the 4. So that was going to give us 5x minus 15 plus 4, which is negative 11. So we've got to collect the like terms. Then after that, remember, this is a linear equation now. It is not a quadratic. We no longer have those brackets. What we just have is a basic linear equation, a basic one. So the question is, how are we going to solve this basic linear equation? Remember, collecting like terms. So you can take the minus 5x to the left-hand side. It will be negative there. Negative 7x, negative 5x. We can also do the same on the negative 21. The negative 21, we take it to the other side. So it's going to be what? A positive 21 there. So that will be negative 11 plus 21. Cross the equal sign, it changes the sign. So let us combine these. Negative 7, negative 5, that is negative 12, which is equal to negative 21, negative 11 plus 21. You can even use your calculator. Negative 11 plus 21, that's a 10. All right, so divide by negative 12 both sides, since this is a product. So that was going to give us the value of x from your calculator. 10 over what? A minus 12, like this, is going to give us negative 5 over 6. So that is what you're going to have at the end. So that's negative 5 over a 6. Just like that. Just like that. So I want you guys to do as many questions of these typical equations. Understand the basics of each. Understand, as long as you've got the basics, guys, you won't be having all of these steps because you know, okay, this one I'm supposed to have it this way. So that is it. On question 3.13, we are given also to solve for x. To solve this equation, that is, we are given 16 times 2 to the exponent of x minus 1 is equal to 0.5 to the exponent of x minus 4. All right, so this is what we have, and we are supposed to solve for x. How can we solve for x? If we are to consider here, we can see these can be written in the same base, which is the base of 2. Remember 16, we can just say 16 is equal to, then shift, you press fact. This is 2 to the exponent of what? Of 4. So it can be written in the base of 2. The 16 that we are seeing here can be rewritten in the base of 2. So it means we have got 2 to the exponent of 4 times, that's a product, 2 to the exponent of x minus 1, which is equal to 0,5. Remember, guys, 0,5 is 1 over 2. 0,5 is equal to what? 1 over 2. That's 1 over 2. And 1 over 2, we understand from our mathematics, guys, that if 0,5 here is equal to 1 over 2, it simply means 2 to the exponent of negative 1. Remember, 1 over x, that's x to the exponent of what? Negative 1. So where we see the 0,5, we see the 2 to the exponent of negative 1. Okay, let's do this. 2 to the exponent of negative 1. We have got 1 over 2, which is what? 0,5. That's the 2 to the exponent of negative 1. Just like that. So questions can be of that nature. So meaning to say on this 0,5, we can rewrite as 2 to the exponent of negative 1 here. It is same as 1 over 2. It is same as this one. One and the same thing. What we want is the base of 2. Not a fraction, not a decimal. So this was the best way in exponential form. But remember, it is also raised what? To the exponent of x minus 4 as originally given. So this is what we have. All right. So at least, guys, we can see some hope because we have got what? The same base of 2. But let us simplify first. Let us have a single base on the left-hand side, a single base, a product of the same base. Remember, you add the exponents. So it was supposed to be 2 to the exponent of 4 plus you add this exponent, x minus 1. So 4 minus 1 is what? Is 3. So that was going to be 2 to the exponent of x plus what? 3, or 3 plus x is just the same, which is equal to, how do we simplify this condition of an exponent to an exponent? You multiply them. A to the exponent of m to the exponent of n is a to the exponent of mn. All right? So you multiply the exponents. So it was going to be 2 to the exponent of negative 1 times x, which is negative x. Negative 1 times negative 4, which is a positive 4. Remember, these are two terms, so you have to distribute by that negative 1. At this stage, you can form an equation from the concept that when the bases are the same, if we see this condition that the bases here are the same, automatically the exponents are equal. X plus 3 as our exponent is automatically equivalent to minus x plus 4. So therefore, x plus 3 is equal to minus x plus 4, which is a linear equation to be solved as we are used to our linear equations. How do we solve? We have to group our terms. Minus x to the other side was going to be a positive. X plus x is equal to 3 to the other side was going to be a negative 4 minus 3. So let us add x plus x. That is 2x. All right. Sorry for that. So that was going to be 2x here. All right. So here we're going to have 2x. X plus x. This is same as 1 plus 1. So that's 2x, which is 4 minus this one. That's 1 divided by 2 by 2. So our x was going to be 1 over 2 at the end. All right. So this is the x that I want you to be having from your equations, the way that you solved. At the end, you were supposed to have your x as 1 over 2. Just like that. So these are exponents, guys. As you can see, exponents, exponential equations. It is not just about having the exponents to be simplified. No, we can have a condition where there are exponential equations. I think we managed to go through these ones from our revisions that we had for term 2. Guys, we had a lot of things that we had. Just make sure that you go through as many as you can. All right, on 3.2, this was given. This inequality, 3.21, solve the inequality. Okay, how can we solve this inequality as we are given it on 3.2? So 3.21, we need to solve 2 minus 3x over 4 is less than 14. So there, guys, we are just given one inequality sign. So do not worry about this. Just take the 2 to the other side. It was going to be a negative there. So minus 3x over 4 is less than 14 minus 2, which is what? Which is 12. Remember, 12 is same as 12 over 1. So you can even cross multiply. 1 multiplies this side. That's minus 3x is less than. The 4 is going to multiply this side. So if you multiply by 4 here, 12 times 4 was going to give us what? 48. We need to find x. This is negative 3x. Divide by negative 3 by negative 3. Remember the concept on a division by a negative like this. The inequality sign reverses or the inequality sign changes. Remember the concept. So negative 3 cancels. That's x. The inequality sign was going to change. From here, it is less than, so it is going to change to be a greater than sign. That is the concept. 48 divided by negative 3, that's negative 16. So x is greater than negative 16. X is bigger than negative 16. That is what it means. That was the consideration of our question. So you must be able to know how to attempt these questions. Then 3.22, write down the first natural number that will satisfy the inequality, this inequality that we solved. What is the first natural number? Remember, natural numbers, we are talking about counting numbers where 0 is not included. Where 0 is not included. Counting numbers where 0 is not included, starting from 1, 2, and so on. So if x is greater than minus 6, it's like this, guys. Minus 6, we're talking about values bigger than minus 16. Minus 15, minus 14, minus 13, minus 12, minus 1, 0, 1, 2, and so on. So on these numbers, which are more than minus 16, which one is the first? That is the question. Which one is the first natural number? The first natural number there is what? Is 1. That is the one that will satisfy our inequality. So the natural number that we are going to have representing, remember, x is representing these numbers. So therefore, x is equal to what? X is equal to 1. That was it. All right. So we are done on this one. 3.3, solve simultaneously. So simultaneously, guys, it's in your hands. We have got two equations. This is our equation 1, and this is our equation 2. So it's up to you. Which method are you going to use? Elimination, substitution, elimination by substitution, anyone that you are capable or that you're comfortable of using. So using the substitution method, I'm going to work with equation 1. Substitution method. So using the substitution method, I'm going to work from equation 1. Let us make y the subject there. So from equation 1, if we make y the subject, it means y is equal to, you take the 2x to the other side. That's 8 minus 2x. The moment it crosses the equal sign, it changes. So we took this one from equation 1. It's now another equation. Remember, we've got equation 2, so we're going to call this one equation 3. We made it from equation 1. That's where we made it. So what are we going to do? We are going to substitute it into the other equation, not equation 1, but another one, which is equation 2. So let us simply substitute our equation 3 into equation 2. So what is it about this substitution? in place of y, wherever y is, we are going to put 8 minus 2x. Wherever we see y, we put 8 minus 2x. That is the idea there. So the question was 2y plus, it was like this. 2y plus 3x is equal to minus 2. But I'm saying where we see the y, this one, the y here, we are going to put 8 minus 2x in place of that y. So it means it was going to be 2 into our y, which is what? 8 minus 2x. So that's it. Plus 3x. Here we do not have y here, so it's just 3x as it is. So that's equal to minus 2 as it is. So as you can see, guys, an equation in x, it's only about x. So you can solve for x. Expand the brackets by the distribution. By distributing here 2 throughout, what were we going to have? 2 times 8, that's 16. 2 times negative 2, negative 4x, plus the 3x that we are seeing here is equal to negative 2. So that's it. We can even collect the like terms on the left-hand side, minus 4x and the 3x together. That was going to give us 16 minus 4 plus 1, minus 4 plus 3, that's minus 1. So it's minus 1x, which is same as minus x, is equal to minus 2. So this is it. We want x. We can take the 16 this side. It becomes a negative there. So it simply means minus x is minus 2 minus 16, which is minus 18. Then divide by negative 1. This is negative. So x is going to be negative. Negative cancels. That's a positive. So our x was going to be positive 18 as it is. So with the x that we just determined or that we just obtained, we are going to substitute this one to find the value of y in any one of these equations. You can use equation 1, you can use equation 2, you can also use equation 3. So as we can see, equation 3 is easier because y is already the subject. Y is equal to 8 minus 2x. So from equation 3, where y is 8 minus 2x, from equation 3, so y is equal to 8 minus, in place of x, we are going to put the 18 that we are given. So that's 2 times 18. So that's it, guys. You can even use your calculator there. 8 minus 2 into 18, that's negative 28. All right, so that one was going to give us a negative 28, as we can see. So that is it, guys. We have got the value of x and also the value of y. So this is our x and this is our y. So questions can be like that. Simultaneous equations. Simultaneous. Solving simultaneously. On question number 4, consider the function that you are given f of x is equal to this, the g of x is equal to this, and these two functions f and g, they intersect at a and at b. Then 4.1, calculate the values of a and c. Where do we have a and c? Guys, f of x is a parabola that we have, a quadratic function, whatever, we do not know the shape, but it was maybe like this. The hx, as we can see, this format is of a linear, a straight line. So these two graphs, they were going to intersect at 2 points, A and B. What is it that we know about these 2 points at the point of intersection? The two functions are equal. F of x must be equal to gx at that point, meaning to say we have got the same value of x. For this condition on these two functions, our x will be the same, y will be the same. At this point, x will be the same for these two functions, y will be the same for both functions. But our question was, calculate the values of a and c. How can we calculate that? Let's use this idea of they intersect at a and b. So if we are to consider a and c are found on f of x, where f of x is just a plane equation where we do not have the values of anything there, what can we do? The point of intersection, besides these properties that f of x is equal to gx, besides those properties, besides that it is a point of intersection, as a point on its, or just to say it's a point, guys, please understand me here. I'm saying when we have got maybe a straight line like this, if a point lies on a line, it maintains the properties that for that equation that you are given or of that straight line, if you substitute the x, you must get the value of y. That one, it does not have any relationship to say it is a point of intersection. No, it does not work that way. Just a normal point, as a normal point lies on a function. If you substitute x, you must get y. So using that idea, A lies on F. Also, B lies on F. So we are going to take those ones to our advantage. A, which is -1, -3, and B, which is 2, 0 like this. These points that we see, these 2 points, lies on what? On F. Just to say a point, it lies on a function, guys. It means if I take the value of x, remember a point is made of x and y. If I take the x, I put it here, I must get the y, which is our f of x. Remember, if we write this, it means y is equal to ax squared plus c. So let's start by point A. Our A, x is -1 when y is -3. When y is -3, so you can form an equation. Y is -3. When x is what? When x is -1. So that's -1 squared plus c like this. So as you can see, we formed an equation. -3 is equal to -1 squared, that's a 1, and 1 times a, that's a. So you're going to have a plus c. So a plus c is equal to -3. We are back to the simultaneous equation. As you can see, there are 2 unknown. So we're going to call this equation 1. We substituted point A. With the same idea, we are going to use the point B. X and y again. What is our y at this point B? So at B, y is equal to what? Y is equal to 0. So y is equal to, that's a 0, is equal to ax squared. Our x is what? 2. So that's a 2 squared, x squared. Our x is 2 plus what? Plus c. So we have formed another equation. As you can see, it has got a and c. So that's going to solve simultaneous equations there. 3 squared, 2 squared, that's a 4. 4 times a, that's 4a plus what? Plus c. That's another equation. So as we can see, guys, we formed 2 equations in a and c. So we are going to solve these equations simultaneously, just like how we solved the previous equations. So it's up to you. Are you going to use substitution, elimination? It's up to you. So as for me, guys, I'm just going to work with the substitution. I can just see the subject from equation 2. As you can see, it's easier. Just going to take this one to the other side. So from equation 2, make C the subject. C is equal to what? 0 minus 4a, which is minus 4a. So we now have equation 3. So we made the subject from equation 2. So equation 3 must be substituted into another equation, which is equation 1. So we're going to have a substitution of equation 3 into what? Into equation 1. So into equation 1, in place of C, we're going to substitute minus 4a in place of C. So it means -3 is equal to a plus c plus our c. Our c is what? Our c is -4a. That's it, guys. Plus and minus, that's a minus. So this is minus 3 is equal to 1 minus 4, which is minus 3a. Divide by negative 3. By negative 3, this was going to cancel. So our a is 1. So that's it, guys. With the a being 1, we can substitute in any one of these equations, or you can just substitute in what? In equation 3. Since c is already the subject there, c is equal to minus 4a, and our a is what? Our a is 1. So c is negative 4 times 1, which is negative 4. So anyway, guys, that you're going to use, but you must have same answers. A must be 1, C must be negative 4. So do not forget these values. We're going to need them later on. We're going to need these values later on. Or let me just do this. We said A is what? A is... A, we got 1 there, so it means this is 1. And C, we got a negative 4. So this is like x squared minus 4. So f of x is equal to x squared minus 4. Just maybe to answer question 4.3, we are going to need that information. All right, 4.2. We are not yet on 4.3. I'm just saying for us to answer that one later on. But 4.2, we need the values of B and Q. So this one is just a repetition, guys. For us to have B and Q, this time we are going to use GX here, where we've got B and Q, but using the same idea, because A and B, they also lie on what? On GX. These 2 points, A and B. So we're going to use the same concept, just like what we did, guys. GX is equal to BX plus what? BX plus Q. So let's start with A. This is X. This is Y here. So like I said before, in place of GX, it simply means Y is equal. That is what it means, guys. Remember this? So in place of Y there, our Y is what? A negative 3. So let's substitute from point A. So from A, Y is negative 3. So that's negative 3 in place of Y is equal to, in place of X, we're going to substitute minus 1. So that's B times minus 1, which is minus B plus what? Plus Q. Q is not affected. So we've got we have formed an equation from point A. We must form another equation from B. All right, so let's see. From point B. So from point B, this is what we have. This is our B, X, and Y again. So Y is 0 there. In place of Y, you're going to put a 0. So that's 0 is equal to, in place of X, X at B is what? Is 2. So in place of X, we've got a 2 there. So that's 2 times B, which is 2B plus what? Plus Q, like this. So these are the two equations that we are going to have at end. The one when we substituted the point at A, the point A, and the one when we substitute the point B, we formed two equations. So from the two equations that we have, solve now simultaneously using any applicable way that you understand. Is it elimination? Is it substitution? So it's up to you. As for me, guys, I'm just going to use substitution from equation 2. I'm going to make Q the subject. So I'll take B to the other side, the 2B. So that's 0 minus 2B, which is minus 2B, which is now my equation 3. Then I substitute equation 3 into equation 1 in place of Q. So that's minus 3 is equal to minus B. In place of Q, you substitute this minus 2B. So as we can see, minus 3 is equal to minus 1 minus 2, which is minus 3B. Divide by negative 3, like this. We have got our B there. So that is it. Negative cancels. Sorry for that. So that was going to give us what? A positive, what? A positive 1. So this is it. This is B, which is a positive 1. Then to find the Q now, we can substitute in equation 3, anyone that you want. Minus 2 times B, our B is 1. So Q is minus 2 times 1, which is what? Which is minus 2. So as we can see, we have got our Q and our B, which is on what? Which is on our GX. So it simply means our GX, remember our B is 1, so that's X, and our Q was negative 2, like this. So that is what it means. All right, then after that, they want us to use the answer sheet provided to sketch the graphs of F and G on the same set of axes, Remember, we calculated the A and C, so you substituted. This is what we got on F of X, and this is what we got in GX. So we are going to sketch this one, 4.3, remembering that we are dealing with functions here, guys. The first one being a parabola. So it is best that we know what we are dealing with. Our f of x from the presentation, remember we substituted, it's now x squared minus 4. When we substituted the a and the c that we calculated, that's x squared minus 4. How do we sketch this function, guys? A parabola, remember, we need the y-intercept, which is at negative 4. Remember, the y-intercept, it's on a condition where x is equal to 0. So y is equal to x squared. All right, let us do this way. That's x is 0, so it's 0 squared minus 4. So y is equal to 0 minus 4, that's minus 4. So this is our y-intercept. The graph here is going to cross the y-axis at minus 4, minus 1, minus 2, minus 3, minus 4. Here it was going to cross the y-axis at minus 4. All right, then for the x-intercept, we know that this type of a graph, guys, is symmetrical about the y-axis. It is symmetrical about the y-axis, meaning to say it is subdivided into 2. But if you do not know that, it's not a problem. Just find your x-intercept. You are good to go. So for the x-intercept, or for the x-intercepts, we know that y is equal to 0. So if y is equal to 0, that's 0 is equal to x squared minus 4. You take the minus 4 to the other side. It was going to be a positive 4 equal to x squared. Introduce the square root both sides. So x is equal to the square root of 4, which is plus or minus 2. Remember, there are two possible values of x. X can be positive 2 or x can be negative 2. Remember, these are the x values at positive 2 and at negative 2. This is our positive 2 here, and this is our negative 2. This is it. With this information, it is enough for us to sketch our graph. We know the shape is going to be what? This is positive, so it's going to be a smiley like this, a cup shaped. So that's it. Passing through these values, minus 2 and what? And positive 2, and here at minus 4 in the y-axis, our graph can be what? Can be sketched. A parabola, the shape is like this. So it was just going to be, all right, something like this, guys, from the top. All right, so here it's going to be a curve, which is the y-intercept. Then it goes up. All right, so sorry for that. So we're just going to need a curve. All right, so here it's a turning point. Then it goes up. All right, so it goes up symmetrical like this. So this one is just a sketch, guys. Make sure that your sketch is okay. So that's our F. That's our parabola there, passing at what? Passing at minus 2, passing at 2 on the x-axis, and in the y-axis at what? At negative 4. All right, that's our F. Then our G, remember, our gx is x minus 2, which is a linear function that we are dealing with there. So the g of x, that's x minus 2. That's a linear function. So for a linear, we're just going to need x-intercept. The x-intercept where y is equal to 0, 0 is equal to x minus 2. So take this to the other side. 2 is equal to x. So our x-intercept is at 2. The y-intercept when x is equal to 0, y is equal to 0 minus 2, which is what? Minus 2. So the y-intercept is at minus 2. Remember, this one is a linear, it's a straight line that we are supposed to have at the end. All right, so there we're just gonna need a straight line joining these 2 points, something like that. All right, joining these 2 points. So there we're gonna need this here at what? At 2. Right, something like that. So that's at 2, and this one at what? At -2, something like this. So you're going to have a straight line, this one, passing through the 2 points, just like that. So this is what? That's our G. So the straight line that we are seeing is our G that we have. And as we can see, these two graphs, they do intersect at this point at 2, 0 there. That's a point of intersection 2, 0. Those are the point of intersection that were given before. Remember, they said it intersect at -1, 3 and at 2, 0. So the -1, 3 is the point A, which is this on the left-hand side, this other point of intersection here at -1, 3. That's our point A. -1, -1, -3, sorry, at this point A. The other point is B, this one, which is what? Which is 2, 0. As we can see, those are the exact points of intersection that we had before that we were given. And that's exactly what you're getting on your graph. If you are not getting this, it means your graph is wrong, or these sketches that we have, they are wrong, because you're supposed to have the exact values. Determine, all right, the value of gx minus f of x. Here they were supposed to say the maximum value. They wanted to say the maximum value of gx minus f of x, where we have a difference, a vertical height that we have there, and it is the maximum between the two. The y values, we talk about the y values, where you form a vertical line like here. When you just form a vertical line, like when you form a vertical line like this, you've got a vertical line. It is the same vertical line here, a vertical line. Which one is going to give us the maximum distance? So as you can see, it is the same between these 2 points and also between these 2 points. So they said, let us go back to our question. It must be gx minus f of x. But you look into a vertical distance like this. So to have the maximum distance, guys, our g is the straight line. So when you take along the vertical line like this, you take the points which are lying on G. So here, this is -2 on G. It is -2 minus on F. As we can see down here on F, it is what? -4. This point was -4, where it lies. So F is -4, the value of Y that we are seeing there. So it was going to be -2, negative, that's a positive. -2 plus 4, that was going to give us a +2. So as you can see, it is the same distance even for this one, which is corresponding F, sorry, on G here, it is corresponding at what? At -1 minus the F here, it is corresponding at what? At -3. So if we subtract this one, you are still going to get the same answer of a 2. So either points, you're either going to use this one or use this one. That was going to give us the same value for that maximum value of gx minus f of x. So it is up to you there. For which values of x is gx greater than or equal to, take note, greater than or equal to f of x? Gx is greater than. Gx is the one that we are focusing on. Gx is greater than or equal to f of x. When we have a graph being, or the graphs being drawn like this, where the other graph is greater than another one, it simply means we want a constraint where gx is above or is on top of what? F of x. Where gx, this one, is the one that is on top of f of x, or it is what? Gx. And that moment, that's the greater than. So where do we have? We have to analyze our diagram. From this part, we must analyze where do we have the straight line, because that's our gx, this one, the straight line, the linear function. Where do we have it? On top of what? Of f. So if we start from this side, guys, as we can see, it f is on top. F is the one that is on top. G is below. From here up to point A, the point of intersection, up to A. I want you to see what is happening at A. At A here, we can notice that F here is the one that is below. What about G? G is the one that is on top. Look, the straight line here is the one that is above. The F is below. This one is on top. The other one is below. This is the graph that is on top. It is happening from where to where? From A here up to the point B here. If we check here at point B, the moment we move from that B going this side, the moment we move, are we seeing that F is now on top? F is the one that we are seeing on top, whilst G is below. F is like this, whilst G is like, F is above. The Y values are bigger than that one of G. So meaning to say, where G is on top or above f of x, it is happening in between A and B. Here, it is above. It is on top of what? Of this other graph of f. So what are the values of x? The question is, for which values of x? At A, our x is what at A? Our x is -1. At B, our x is what at B? That is where we have got 2 there. So from -1 up to 2, how do we write that? X is greater than or equal to -1, less than or equal to 2. From -1 up to 2. -1 is included. 2 is also included. Remember, there is an equal to here on our question, where f of x is greater than or equal to. So we must have that equal to as well on our answer. So that is how you answer these questions. You just have to be more careful how the questions are given. Try to attempt them in a better way. Question number 5, we are given on this function that we are seeing, or on this graph that we have. It is a function of f of x is equal to 2 to the exponent of x plus 2 plus k. Then we've got the point, which is 5, which lies on the graph. And it is also the y-intercept. Then as we can see, there is a 1 that we are given. So that's an asymptote. This one from an exponential function, we know this one, it will be our asymptote, which is for the k that we are seeing there. It is limiting the k that we are seeing. So if we check, the first question was for us to use the laws of indices to show that this is the same as this one. So it has nothing to do with the functions, this part. No. It has nothing to do with functions. Use laws of what? Indices, laws of exponents. Go back to the laws of exponents. That is the question. How can we rewrite 2 to the exponent of x plus 2 plus k like this? How is that possible? Remember our laws of exponents, like I said before. The separation that we are seeing when it is like this simply means 2 to the exponent of x times 2 to the exponent of what? A 2. Remember I talked about this, plus our k. So that's it. 2 to the exponent of 2 is what? 2 times 2, which is 4. So it was 2 to the exponent of x times a 4. Remember, a times b is same as b times a, no matter one that you start with. So starting with a 4 is the same as we are starting with 2 to the exponent of x. So you can start with a 4. 2 to the exponent of 2, that's 4, times 2 to the exponent of x, plus our constant k. We are done. We have rewritten in this format. That is what they want. That is what they want. Show that it can be written like this. Then from there, determine the value of k. Determine the value of k for 2 marks. How can we determine the value of k, guys? All right. The value of k, we can see it from the asymptote. We don't need to determine it. You can see it from the asymptote. But anyways, let's say we did not see that. How can we find the value of k? It's either you go to this equation that you rewritten like this, or you go back to the original equation that we had here from the function that we were given. Remember, it means y is equal to 2 to the exponent of x plus 2 plus k. So to find the value of k, I use a point which lies on f. And the point which lies on f is the 5, the y-intercept. Remember, in the y-axis, x is equal to 0. So the 5 as a point, it means 0, 5, x, y. So we have got the y value. Y is what? Is 5. At a condition where x is what? Where x is a 0. So that's 0 plus 2 plus a k, just like that. So 5 is equal to 0 plus 2, that's a 2. 2 squared, that's a 4. Plus k, we take the 4 to the other side. It was going to be a negative 4 minus 5, which is 1. So k is equal to 1. So like I said before, we can take it from what? From the asymptote. That's it. Write down the equation of the asymptote of f. If we have that k, the equation of the asymptote, you don't write as k is equal to 1. No, the equation of the asymptote is the line that we are seeing, this one. It is the line of what? Y is equal to 1. Y, remember, horizontal lines, just like the x-axis, we know this is the line of what? Y is equal to 0. So y is equal to 1, y is equal to 2, y is equal to 3, y is equal to 4, y is equal to 5. That is how we name the equations for the what? For the horizontal lines. They are in the form of y is equal to. So our equation of asymptote, that was y is equal to 1, given on the diagram, or we can take it from that equation of f of x, since we said our k is 1. K represents the asymptote. This part here is of the asymptote. Y is equal to 1. So that is it. On this one, y is equal to 1. As you can see, it was just a 1 mark that we are given because it's a straightforward question where we can take it from the graph or from the equation. So with this, guys, that was it for this control test that we had for our June 2024. Let us try to have as many questions as we can. We are going to have other provinces also done. So if you have got, if you are from a certain province and you feel like we need more revisions pertaining what is of your province, let me know on the comment section. If you have got the question paper, then you can simply send me that question paper so that I work on it, preparing for the tests which are ahead of time. But for now, guys, that's it till we meet again.